everyone. We're going to talk about stacks and queues, and I'm sorry I can't be with you today. I'll see you next week. Doing well. Stacks and queues. Now these are two different types of data structure. So a stack and a queue are both types of data structure. And let's start talking about a stack. Now, just as the name suggests, a stack is can be thought of as sort of a vertical list, if you like, of items, whereby each item that you place must be placed on top of what was there already. So you can only place, let's say like a stack of plates, you can only place plates on the top of the existing stack. Now the process of adding a new plate, if you like, to the top of the stack is called push. So you push some item on top of the stack. So this is the top of the stack here, and the top of the stack is always the item that's on the very top of the stack. What we're not allowed to do in red here is to remove this. So we cannot remove items from the middle or the end of a stack. Instead, we must remove items from the top, and that removal process is called pop. Okay, so we have push, which places an item on the top of the stack, and the top is made to point to that item. In a stack data structure, it's usual to have a property called top, and whenever you use top, it's meaning what's on top of the stack. So therefore, if we push something onto the top of the stack, the top that used to be at the top is no longer at the top, and therefore top needs to be changed. Now pop what that does is it removes the element at the top of the stack, or the item at the top of the stack, and it returns that to you. So for example, you might have a bit of code that says value at top is stack dot pop, something like that. Now of course what happens then is that the property called top would no longer point to that thing that you just removed, but would point to the one that's underneath it, because that would then become the top of the stack. And of course, if you're implementing a stack data structure yourself, you need to take care of that sort of thing to make sure that the property called top is indeed the top of the stack. Now in some programming languages and some texts, they refer to the top, this idea of peeking what's at the top, called the peek value, as if you're peeking inside to see what what the value is. So we could just say peak, the peak value. The easiest way in Python to implement a stack is just simply using the existing list that you've been using. So we can say something like, in Python, we can use the list data type. And the reason being is that list has methods. So the list data type already has methods. Called pop, and it's not called push, but it's called append, and you've been using append already. So let's say you had a list in Python that looked something like this. So let's say you declared a variable called myList is equal to, and this is a list of strings, which is why I've got quotes around them. Like that. And then I said myList dot append, and I append, let's say, the string 12 on top of that. Then the myList would obviously look like this then. So put a little comment here. MyList becomes 3, 7, 9, 6, minus 1, and 12. So it looks as though append is dealing with this final element being the top of the stack. Okay, so if you like, it's turning this this list that we're usually writing left to right, so that the furthest right becomes the top of the stack, almost like turning the list 90 degrees anti-clockwise. And also in Python we have pop. So if I say myList, so I could just say something like this. I could just say my value at top is myList dot pop, and that would return whatever's at the top of the stack. Now in this case here it would give you this string value of 12 and then return the list to how it was to start with, because the 12 has been popped off the top. Now there is a danger in using the inbuilt Python list type, is that the list type does have excuse me, other methods on it, and certain methods goes against what a stack does. So for example, the method called insert, and you insert into a certain position, so 3, and you insert, let's say, x into your list. That inserts x into the list at position 3. So in this case, position 3 here would be there. That goes against what a stack does, because a stack should only enable you to take things off the top and push things onto the top of a stack, and not get them from the middle or from the bottom. And that's the disadvantage of using the list built-in data type. But as long as you're careful, you should be fine. Now one of the things that we could do, of course, is to encapsulate a list inside a excuse me, inside a class, which hides the ability to use the insert method or other methods that go against what a stack can do. So I'm going to quickly write some code now, and I'll be back in a couple of seconds and show you what I mean that would basically remove this danger of using the list data type in Python and therefore breaking what a stack actually does. Okay everyone, so what I've done is I've created some code now which I'll add to your OneNote. I'll add a new tab called stacks, and this code will be underneath there. So what I've got is a class called stack. It's just descendant from this very basic object. It's got a constructor, and in the constructor I define a private property called __ items, and that's just a traditional Python list. So I can do anything with that list within this code here. But by making it private, I'm essentially making it so that you can't access this list from outside of the class. So for example, when we're down here, when I create a stack, this is an instance of my stack called my stack. I'm not allowed to say something like my stack dot __ items. I can't do that because it's a private property, so this isn't allowed. So essentially what I'm doing then by making this private is I'm hiding the ability to remove items from the middle of the list, etc., which is what we want for a stack. Instead what we've got is the ability to pop and push and look at what's at the top, or peek, if you remember. I've called it top, but we could have called it peek, and also print the stack. Now, in a minute, I'll show you a run of this code. Let's just have a quick look at the pop method first. So I'm just checking that if there are actually some items on the stack, then I return what's at the top of the stack, which is the pop of the list. Okay, so if there is something in the stack, then I return pop, which is at the top of the stack. Now remember, our list looks something like this. So I might have David, Oscar, Momin, and it's this right hand side of the list that is the top. Okay, so the top currently is Momin, and these are the items that I'm not allowed access to at the left hand side. So basically you could think of this as being rotated 90 degrees, making my stack would look something like this: Oscar and then David to here. So this is my top. So in my print, method, what I'm doing here is I'm going to go through the list backwards. So and print the items along. And if it's the first one, in other words, if it's the top of the stack, I'm going to add this little bit of text called and a little arrow pointing to the top of the stack, just to illustrate where the top is. So I'd like you to take this code in a minute when I've finished speaking, and just put a breakpoint in each of these methods, and just check that you understand how they work. Push is straightforward. I just use the append list, and I'm going to append this item through the parameter and item onto the list. Top, all that does is returns none if there's nothing there. If there are some items, in other words, the length of the internal __ items list is greater than 0, then I return what's at the top of the stack, which is of course the 0th element. Actually, that's incorrect. I need to correct this. The 0th element is of course this element, which is wrong. I should be returning this one, and there's a quick way of doing that. In actual fact, so this, I need to change this in the code. This should be, in fact, this whole line here should say return self dot items, and what I can underscore items, sorry, and I can put in -1 here, and this -1 is a special way of saying the last element in the list. So I'll put a comment in there, last element. I'll change that for you and you copy over the code. Okay, from the last slide, I have indeed changed this correctly, and I've run the code. So it creates this variable called myStack, which is a stack object, and pushes David onto the top, so the top of the stack will become David. Then it pushes Oscar on top of the stack, so Oscar now will be on the top of the stack, and then I'm asking it to print. And when I print, I get this. So it prints them in reverse order because Oscar is at the top of the stack, and it shows me that a little arrow where the top of the stack is. And then I just print the stack again. That's what this is doing. And then print the top of the stack is, and then ask what the top of the stack, this peak or top function, which is this one, which returns the -1th element. And the -1th element is actually always the last element, which is a nice thing to be able to do. So you can see that the top of the stack is actually Oscar. So I urge you now to go to the tab in OneNote. You will find this code, and I'd like you to play around adding some code at the bottom, pushing and popping elements off the stack.